or what we call TIG. A lot of people call TIG or Healy arc, was a common slang term for it, I should say, back during the day. The technical term is gas tungsten arc welding. Okay. Used a process also known as Healy arc used today. Figure 1-3 in your book shows a pipe on a plate using, it's an aluminum weld made using the TIG process. Most of you are familiar with it. You're going to get a chance to do the TIG welding process in our shop. We'll explain a lot of differences and show you examples moving forth through the program. The company perfected a water-cooled torch capable of high amperage. Now that's important because the tungsten electrode can be anywhere from 1/16 up to, biggest I've used is 1/8, but I think they go to 3/16 as well for larger. But you're running anywhere from 40 or 20 amps all the way to 240 amps, and that's a severe amount of heat coming out of that one little bare electrode. So it has a tendency to get hot. Not only that, but it has a tendency to get hot in your hand as well. To keep from burning up equipment, the water-cooled torch was put in, especially for aluminum. It helps stabilize and keep it more consistent as far as the heat flow. Anytime you're welding, the hotter your electrode gets, whether it's a consumable electrode with shielded metal arc welding, to where you're using up the material as you're welding it, or a gas tungsten arc welding process where the tungsten is not being consumed, it's just your heat source, it still gets very, very hot. And the more you use it, the longer you use it, it gets hotter. So when you start out, it might be 5,000 degrees at the weld puddle. But after, say, 30 seconds of welding, it might be closer to 6,200, 7,000 degrees, so forth. Okay? As we're welding along, it gets hotter. It's harder for you to keep hold of that, even with big, thick gloves on. Okay? Okay, we are in the book, page 6, chapter 1. Left-hand column, go down 3 paragraphs, and I want you to look at where it starts out. In 1948, the U.S. patent. Okay, you're always welcome to read through the rest of the PowerPoint. If I have to read all of it, it's going to take hours on the video. So I'm skipping through, hitting some highlights that I think are important. Again, if I'm reading it, you're more than likely going to want to highlight it, and you might be seeing it on a test. Okay? So the U.S. patent issued in 1948 for gas metal arc welding process. Let's go back to the book, page 6, chapter 1, left-hand column. 1, 2, third paragraph down. It starts out, 1948, the U.S. Patent Office issued a patent for the gas metal arc welding process. The gas metal arc welding term superseded the earlier terms of metal inert gas and metal active gas. Okay, let's skip down 1, 2, 3, 4, 5, 6 sentences into the next one. Right in the middle of the paragraph, it starts out and it says, the use of GMAW has increased very rapidly. It is now used in virtually all industries. A GMAW or similar process is responsible for over 70% of welds being performed today. So there are several different types of just plain wire welding. A lot of us will think of MIG, and they have different applications, different advantages and disadvantages to each process as well. So for example, GMAW is just a bare wire electrode, gas metal arc welding. Now it can be lumped into the same group as flux core arc welding because flux core arc welding is a wire. However, it has additional flux. It can be used with flux or without flux. Just a quick example real quick. GMAW solid wire, depending on which process used, so there's short circuit, there's globular transfer, there's spray arc, thermal arc, so forth. They each have different characteristics. So one of them might be deep penetrating, the other one might be very shallow penetrating. So for example, short circuit transfer, which most of us are going to do in the shop, is a very shallow penetrating welding process. You have to be very clean. It's very technique driven. We want to maintain that so that we get good quality welds. All right, right-hand column, back to the book, chapter 1, page 6, right-hand column, halfway down. Let's look at all the bulleted items there. So we start talking a little bit here about flux core welding, arc welding. Now see here real quick the difference between flux core arc welding -S. This is self-shielded wire. FCAWG, which has an external shielding gas as well. So they both have a flux core. So in the center of the tubular, it's hollow like a pipe. And in the center has flux, granular flux on the inside. Self-shielded, that's all it uses. On gas shielded, it uses the internal flux coating, the granular flux, it consumes it. Plus there's an external shielding gas on the outside. So you get double protection as far as shielding gas or qualities, okay? So here's the bulleted items, right-hand column on the book. I want you to look over them. You don't have to remember them, but just start familiarizing yourself with the different welding processes that are out there. Arc spot welding, atomic hydrogen welding, electro gas, plasma arc, stud, submerged arc, underwater. There's a ton of them, okay? And with new technologies and new advances, there's more and more every day. Well, I shouldn't say every day, but quite often we're finding new advancements within the welding processes to make them a lot more efficient, a lot more of a pure weld or a strong weld, so forth. All right, page 7, chapter 1, top section, come down the first paragraph. It starts out, currently 5 welding associations provide guidance and standards related to the welding industry. So, let me back up one step. Right after the bulleted items that we just covered, okay, I want you to take note of this. There's over 90 welding processes defined. That's kind of important that you know that. Because we're used to seeing 3 or 4, there's a main 5, that's what they call it, but there's over 90 processes defined. They might be used without different industries across the world today. Okay? All right. We're going back to page 7, left-hand top column, first paragraph. Currently, 5 welding associations provide guidance and standards related to the welding industry. Here are the main 5. The American National Standards Institute, American Petroleum Institute, American Society of Mechanical Engineers, the American Welding Society, and American Bureau of Shipping. Okay? So, sorry, I have to give me a drink of water here. ANSI is a welding association. However, they test welding procedures. They do not write welding procedures. It's kind of an important thing to know. Okay? The American Petroleum Institute, this is mainly for cross-country pipelines, crude oil, so forth. However, it's important to know that API oversees not just the pipeline itself, but also refineries of petroleum products as well. So here in Central Oregon, we may not have a whole lot of pipelines going in and out of here, but we do have several refineries that might be used and processed within the state, California, so forth, okay? At that point, API, the 1104 code is the one that we're going to want to regulate and use, be welding to those specifications within the API 1104 code. All right, ASME, the American Society of Mechanical Engineers, is usually the one that we deal with, we're talking about boiler piping and pressure vessels. So a lot of times when you hear people talk about power plants or the powerhouse or pressure piping, there's ASME. Now there's different sections within ASME procedures as well. There's B31.1, B31.3, so whether it's process piping or pressure piping, these codes are the standard that the engineers have developed to keep the welding and engineering of products safe within this industry, okay? The American Welding Society covers several of them as well. Structural steel. AWS D1.1 is the code for structural steel welding. It's the most widely used code in the world. And then the American Bureau of Shipping as well. Okay? They provide guidance and standards relating to the welding industry. All right. Welding is an occupation. Go to your book, chapter 7, left-hand column. A student needs to learn all phases of the trade. Welding, reading, drawings, math, computer knowledge will secure a successful career. Many qualified welders are certified by the American Welding Society, ASME, and API. The tests are difficult and require many hours of practice. So let's talk about certification versus qualification for a minute. Everybody hears that you want to get certified to become a welder. Okay? A lot of times people think coming to a college, you're looking at a one-year welding certificate. It means you're going to come out certified. That's not the case. Let's be very clear about that right away. Our certificate, our one-year welding certificate, is so to say, a baby diploma. Okay, there's the associate's degree, the 2-year associate's degree. Then right below that is our 2-year certificate. So there's a few different standards that you have to make, or a few extra classes you have to take to get the full associate's degree. Now you may not have to take as many classes to get the full 2-year certificate. So you may not have to take, just for example, Psychology 2 versus Psychology 1. Does that kind of help make some sense? I'm hoping. 1-year certificate's the same thing. It's about half the credit loads, typically 45 roughly to 50 credits. But it's very, very heavy on, so for example in the manufacturing, it's the skill-based courses versus academic courses. Okay, so the academic courses may be your English, writing, psychology, business, computers. By all means, and those are very important courses as well to take. But that's the difference between the associate's degree and the certificate. The certificate, you're coming out of here with a 1-year track, trying to get the skill-based knowledge to get out there and go to work right away. If you have time, I strongly recommend and suggest going for your full 2-year associate's degree. A lot of the technical documents that we read are written by engineers, people that have spent a lifetime writing technical documents, and they're sometimes very difficult to interpret, especially if you've not been around them that technical document reading very much. So, get back to where we were at as far as certification versus certificate. The certificate's just saying you come out here with a certain amount of hours to prove that you have training in that field. However, the certification, you don't have to go to school at all. I know several welders I welded with for a long time that never stepped foot inside of a college classroom or a high school classroom. They picked it up, they learned it through a trade, hired on as an apprenticeship, or just started doing the welding as a career. The certification means that you can do a certain weld within the code specification, within the acceptance criteria of that code. So for example, we go back here, and if say we're welding to AWS D11 structural steel welding code, plate, 1-inch plate, unlimited thickness, you have to weld a 1-inch thick plate all the way from top to bottom. It has to be 100, or not 100% pure, but within the acceptance criteria of what that code is calling for. So for example, you might be allowed 1/8 of an inch of an air void in that weld per coupon or per weld. Depends on what the code specifies. Now ASME, depending on what you're welding on, if it's in the pressure vessel, it may say that you're only allowed 1/16 of a discontinuity within that weld. I know, beginning class, a lot of terminology that's being thrown out. You're kind of confused with it. Feel free to look it up, read through your book. You're going to pick it up. Don't hang up on the small things like discontinuities. Do I have to know whether it's an 1/8 inch, 1/16? Not now. By the time we're done with weld 2, weld 3, going forward, you're going to understand this. So I'm going to help explain it to you, okay? But it's important to know that there's a certain level of quality that you have to achieve in order to be a certified welder. And right before that certified welder, there was a qualified welder. So let's explain the difference. If you're a qualified welder, it means you performed this weld within a code specification, and it complies within code standard. It's acceptable, everything. You are a qualified welder. You do not become a certified welder until a certified welding inspector writes you the actual document stating that you're certified. So I can test a welder because I'm a certified welding inspector myself, and if I test a welder, he can pass the weld, and at that point he's a qualified welder. I gave him a verbal, or we've seen it, we've destructive bin tested it, yes, it's verbal, you have passed it, you're a qualified welder. He does not become a certified welder until I have completed the paperwork and put my stamp on it saying that he has welded that weldment in compliance with whichever code we're welding to. A little bit of a difference. I just wanted to clarify that up. That's one of the first questions we get asked when we come into the welding program. Hit me up about any questions you have, concerns, so forth, going through. All right. The tests are difficult and require many hours of practice. So, you're not going to be able to do one weld once good, you're going to have to do it several times good. You're going to hear me several times tell you, okay, you've done it, it looks good, go back and let's prove it. Because you have to be able to do it day in and day out as a welder. You may make 10 6-inch welds in a day on Schedule 160 pipe, 1-inch wall. When you're done here, you should be able to perform that weld within a code quality and acceptable to all visual criteria and destructive bin test criteria as well. Okay, so we're going to go back to the book. We talked about welding as occupational. Let's drop down to gender friendly. Welding, the material that we work with, does not care whether you're a man, a woman, a child, whether you have disabilities or anything else. That material there, all it cares about is how you weld it or how you machine it. It doesn't have any prejudice towards it. We expect the same in our program. We will help you get to the level of the quality to be able to do that weldment. However, we do not care whether you are a man, a woman, a child, an elderly person. Doesn't matter. The material doesn't matter. There's no need for us to matter or to care either. Okay? This is one of the biggest things. However, just like anything else, sometimes your co-workers might be difficult to work with. Does not mean it should slow you down at all. All right. Done in every civilized country in the world. So, I don't really like the way that that's necessarily worded. That doesn't necessarily mean that every weld we have to do, even in the United States, has to be a certified weld. That's not the case either. Certain times there are jobs that are done that don't have to meet certified weld criteria or code criteria. However, the reason you're here is to learn how to do a quality job on a product. So keep to your personal standards and quality, but just know that going out there, not every weld you make in the world is going to have to be a certified weld. That's kind of a misconception as well, okay? All right. So we're all back to the book. Page 7, chapter 1, right-hand column, bottom paragraph, industrial welding applications. Welding is not a simple operation. More than 90 different welding processes are divided into 3 major types: arc, gas, and resistance. There are a number of other types used to lesser extent: induction, forge, thermite flow, brazing. Don't think that these are any less important welding processes. Every welding process has its strengths and it also has its weaknesses. For example, brazing, an easy way to join copper, brass, so forth. At one point in my career, we had a snowplow truck that went down and had the PTO going through the center of the radiator. And the radiator had popped a hole in it, and it was a brass plate and copper tying in together. It was an older snowplow, right in the middle of winter in Wyoming, and big snow had come in. We needed the snowplow. It was the only truck we had to clear the roads for people to come in and out. It would have took 9 months and $5,000 to order that one radiator. They would have had to start building it. However, just a little bit of patience and some time and being very diligent with my heat flow and making sure that I prepped everything right, I was able to fix that radiator by brazing it up and it'll hold pressure to be able to get that snowplow back on the road right away. It's very important in maintenance welding. Equipment time or downtime within equipment, mobile equipment or industrial running equipment, very important within a business, because if the equipment's not running, usually we're not making a profit for the company. Okay. Resistance welding. Spot welding, seam welding. We'll talk about this a little bit more as we go on. We're just going to hit the highlights, okay? So spot welding, seam welding, flash welding, projection, other similar processes performed on machines for different things. Example, very thin material, may just have to have a nice little spot weld up and down it to be able to hold some structure, or a light material as well. It doesn't always have to hold pressure, okay? Semi-skilled workers do not need specific hands-on welding skills. So a good example of the spot welding is for HVAC work, which I used to do HVAC work as well. Just to be able to join the insulation to the inside of the ductwork to keep it to where you don't get as much heat loss through the ductwork, and it also quiets down the airflow as well. You would take and you'd have the sheet metal here, and then you put your layer of insulation on it, and you take spot pins, and you would put them through, and you would zap them, and they would spot weld to the ductwork on the other side, and that would keep your insulation straight up and down to where it wasn't falling over, and it would keep it nice and snug along with some glue on the back side. You don't have to have a lot of shoulder metal arc welding experience or skills in order to do that operation, okay? However, it is still